In this particular video, we're going to create an image recognition system. Here's a step-by-step guide for creating an image recognition system using TensorFlow. First step is data collection and preparation. So dataset selection, choose a dataset suitable for image recognition task. Popular data set include Cypher 10, Cypher 100, MNIST, ImageNet, etc. We have used MNIST before in one of the examples, but we'll see more. Data preprocessing. Pre-process the images by resizing them to a uniform size, normalizing pixel values, and converting them to arrays. TensorFlow provides tools like ImageDataGenerator for pre-processing. Step 2. Building the Convolutional Neural Network or CNN model. Model architecture. Design a CNN architecture suitable for image recognition. You can start with a simple architecture like LeNet or use more complex architectures like ResNet, Inception, etc. Model definitions. Define the CNN model using TensorFlow's Keras API. Specify the number of convolutional layers, pooling layers, fully connected layers, and output layers. Step 3 is model training. First one is data augmentation in there. Augment the training data using techniques like rotation, scaling, shearing, etc. to increase dataset diversity and improve model generalization. Next, compile the model. Compile the CNN model by specifying the loss function, optimizer, and evaluation metrics. Next, training. Train the CNN model on the training dataset using TensorFlow's fit function. Monitor training progress using callbacks like model checkpoint and early stopping. Step 4 is model evaluation. Validation. Evaluate the trained model performance on the validation dataset using metrics like accuracy, precision, recall, and F1 score. Fine-tuning. Fine-tune the model architecture and hyperparameters based on validation performance to optimize model performance. Step 5 is model deployment. Save the model, save the trained model, weights, and architecture using TensorFlow's save function for future use. Deployment. Deploy the image recognition model using a suitable deployment strategy such as deploying as a REST API using TensorFlow Serving or Flask. Step 6 is continuous improvement. Monitoring and maintenance. Monitor the deployed model performance in real-world scenarios and update it periodically with new data or fine-tuning to maintain accuracy and adapt to changes. Let's look at an example of how you would implement this if you do it in Python. So first, import TensorFlow, then import layers and models from Keras. Now let's build the CNN model. So first, you're going to take the models, you can create the sequence, call the sequential function and pass the conv.td and pass the parameters to it. You can then do the max pooling 2D, then again conv.2d and then max pooling 2D. Next again conv.2d, pass the parameters and then flatten it. And then to add some dense layers, call the dense function and pass the parameters. Again call the dense functions with the parameters using softmax as the activation. So this will build your CNN model. Next is model training. You can first compile using the optimizer, loss function, and metrics. Here we're using Adam as optimizer, sparse categorical cross entropy as the loss function, and for metrics we're using accuracy. Next, fit the model by calling the fit function and pass it to history, where the arguments are trained images, train labels, epochs of 10, and validation dataset is test images and test labels. Step 4 is model evaluation. Now we can get the tuple for test loss and test accuracy by calling the evaluate function and pass test images and test labels to it. You'll get the test. You can print out the values that you get. You can next save the model and deploy it using Serving or Flask. Continuous improvement step is where you monitor the performance, fine-tune the model, and update with new data periodically. So this is the entire steps for actually creating an image recognition system. This example demonstrates how to create an image recognition system using TensorFlow. You can customize the model architecture, pre-processing techniques, and deployment strategies based on your specific requirements and dataset characteristics. You can look at some of the previous videos where we have done this. Additionally, consider exploring advanced techniques like transfer learning and ensemble methods to further improve model performance.